Middleton Lawn and Pest Control has devised a new technique for treating drywood termites that virtually eliminates the use of tarps and fumigations. It's a non-invasive approach to controlling the individual galleries for drywood termites. With this technique, there's pieces of equipment that we use to identify, first of all, where the termites are located using sound equipment. That's the AED 2000 acoustical device. Now, once we've located the active termites, then we can drill into the galleries, identify where the galleries are located with the resistograph, which is a modified hand drill. And finally, we can treat the galleries with a foam process that will take Termidor, which is a termiticide, and coat the galleries with that. Therefore, eliminating the infestation and with a non-invasive surgical approach to drywood termite control. Now let me show you some of the equipment that we were talking about. This piece of equipment is the AED 2000. It's an acoustical device that will actually pick up the sounds of the termites eating the wood or breaking off the wood fibers in their galleries. It's a non-invasive. You don't have to tear the wood up in order to listen to the termites. With this probe, it's just touched to the wood, and then with the device and listening, we can hear the termite sounds, plus we can get a digital readout of the intensity of the sounds and the number of hits that we get. With this, then we can stair step onto the wood and find exactly where the active termites are located in the piece of wood that we suspect. Now, once we've identified the area of concern or where we have activity, the challenge is to find where the galleries are located in the wood without tearing the wood apart. With this piece of equipment called the resistograph, it has a very small drill bit, about the size, about 1/16 of an inch in diameter and about 6 to 8 inches long. We can drill into the wood, and the drill bit measures the resistance of the wood. When we hit a gallery, we have no resistance, so we get a printout of the piece of wood that we're drilling through, and we can determine how deep into that wood the galleries are located. Once we've identified the galleries, with the drill hole that we just used to find the galleries, we can place this small treating tip into the termite galleries and apply foam similar to shaving cream. And in this foam is a termiticide, and this coats the galleries. And once the foam has dissipated or has dried into the wood, it coats those galleries with our termiticide, which is Termidor. And as the termites are moving through this, they come in contact with it and it destroys the colony. What we're looking at here is an active site for drywood termites. One of the indications that you have a drywood termite problem is the fecal material that is given off by the termites. What they do is they clean their galleries of this fecal material. They're small little grains, almost looks like sand, but they're kind of football shaped with 6 indentions around the perimeter of it, but it's very small. This fecal material is kicked out of the galleries or the termite colony area. So this is an active infestation right in here and gives us an indication. What we have to be able to determine is where is the live termites located and where are the galleries located. And that's where the acoustical device, the AED 2000, is utilized to touch this wood to find out where these termites are located in this wood instead of trying to tear all of this out. And I'll just move it down. What we're doing here is we're listening for the sound waves that are traveling through the wood of the termites breaking off small particles of wood as they consume it. We have 2 ways of determining that we have activity here. One is by sound, because they make a distinct sound, and 2 is by a digital readout of telling us how intense those sounds are. And by stair stepping, we can identify and isolate exactly where the colony is located in this wood, which until now really has not been a success with other pieces of acoustical equipment. With this piece of equipment, the AD2000, the filtering mechanism in here and the ability to not tear the wood up is what really sets it apart from anything else. So each time that we have hits, it'll show up like that. You'll get digital readings on it. See, we get nothing. We do this again. Go one more time. See, those were the readings that we were getting. And the car going by, we picked up no sound from the cars. The only time we could pick up other noises would be if somebody were to touch this, tap this, stomp on the floor. But it's a very distinct sound. It doesn't sound anything like termites. Now, once we've been able to identify the sites, and what we normally do is when we have the activity, we'll use a little sticker. We'll place the sticker in that area there. Now, sometimes the galleries may be close to the surface and we can actually feel the weakness in the wood because these termites eat right out to the surface but leave that surface undisturbed, so they're cryptic, they stay inside. So sometimes we can feel the galleries or feel where some of the damage is located. A lot of times we can't. So from this point, we'll start drilling with our resistograph and we'll do a series of 3 holes. Move down, another series of 3 holes. And this will give us a profile of this wood and where the galleries may be located in there. And once we've done that, with the drill holes, we'll use our foaming equipment to foam into these holes. And then that will penetrate the galleries. It'll move up and down, sideways, and totally coat the galleries that's in there. If we look down here, we have our droppings from our drywood termites that are on the floor. So they're coming from straight above. We would logically think when we get into this area and use our acoustical equipment, we find that there's no activity here. So where are the droppings coming from? Where's the activity located? If we start looking at this, there is a slope to this backside of the stairs. And so what we've done is we've gone up and started looking for activity up higher because more than likely the droppings have come down from a kick-out hole inside this area, hitting a stop and then falling straight down here. As we inspected this up here, we did find at the top of the stairs, we found the activity. So we'll be treating that area up there. So that's where the termites are actually located, but this is where the droppings were ending up. Now what our technician is doing here is he's checking that area there of concern. We have droppings on the floor, but we're having difficulty determining exactly where those droppings are coming from because of the slope of the stair. All right, okay. In thin pieces of wood like we have in this stairwell area, it's difficult to use the resistograph because the wood is so thin. So what we've been able to do is find the kick-out holes using the acoustical equipment. And now what we'll do is with a hand drill and a very small drill bit, we'll drill around those kick-out holes to gain access to the gallery and then put the foam into those galleries because these galleries are very, very thin because of the depth of the wood or thickness of the wood. And now we've treated that gallery up there. As the termites come in contact with the termiticide, it will kill them. We have a kick hole right over in here too, which is an indication. This is the kick holes are where the termites actually bore through the wood a small hole to throw these pellets out, and we call them kick holes. This gives another indication of where the galleries could be located. Oop, there we go. This is where we entered the wood right here on the graft. As we penetrated the wood about 1/4 of an inch, we hit a small gallery. As we continued through the wood at about an inch, about I guess pretty close to 3/4 of an inch, we hit a pretty good sized gallery right here. And that gallery probably, it's a 1/4 inch deep. Then we went through the rest of the wood. It's good and sound. So we've isolated into that profile of the wood a gallery. It's located right in here. Now what we're going to do now is we'll use our foaming equipment. Go in, looks like 3/4.
That's about it.
Yep. What he's doing here now is just enlarging those holes just a little bit to accommodate that needle. Look at it traveling along there. It's coming up through the cracks that the termites have put in the wood.
Push it from the other end.
It's a second gallery. You're blowing them out right through here. That's the good thing about the foam. It seeks out those areas and travels along those galleries. With fumigation, to fumigate a large area, usually the fumigation is set up on 1,000 cubic feet. So if you're looking at a large building, for instance, this building here we're dealing with is probably pretty close to 500,000 cubic feet. They would have to put tarps over the entire building, and this is 3 stories plus a basement and plus an attic area. So they'd have to put tarps on the outside of the building covering the entire building, and then pump gas in here at the rate of so many pounds per 1,000 cubic feet of this poisonous gas that would penetrate the wood to kill the termites. There's a couple of drawbacks with that. One, the cost is very expensive. Two, once you take the tents down and the gas dissipates, there's no residual. That means the area can be reinfested or attacked again. Where with our process, we surgically find each one of the sites, treat those sites, and that product that we put in there gives us a residual, so we won't have a problem in that area again.